Alright, so now we're going to go over some example problems on how to use these trigonometric identities to solve problems. So the first one asks us to find the values of all 6 trigonometric functions given that our secant is -3/2 and that our tangent is positive. Okay, so let's go and let's start this off. So we've got secant of u, and u's fine, as being -3/2. Well, I know that the secant of u is going to be the same as 1 over the cosine of u. Okay, so if I know this, then I can go ahead and say, okay, well, the also that the cosine of u is 1 over the secant of u. So I'm going to say, okay, so the cosine of u, that's going to be 1 over -3/2, okay, which is going to be, if we simplify this off, -2/3. So these two are solved for us. So now we got to go through and find out, well, what are the other ones going to be? It's going to be a little more complex. We've got to use our different trig identities. So the next one that I'm going to want to find is going to be my tangent function. So tangent of u is equal to sine over cosine. Well, I don't have my sine yet. But what I do know is I do know that tangent squared of u plus 1 is going to be my secant squared of u. That's one of those Pythagorean identities that we've used before. Okay? So since I know what secant of u is, I'm going to go ahead and replace that and solve. So I'll have tangent squared of u plus 1 is going to equal -3/2 squared. So my tangent squared of u plus 1, this is 9/4. My tangent squared of u is going to be 9/4 minus 1 when I subtract the 1 over. So my tangent squared of u, now when I subtract these, I can think of this 1 as being 4 over 4. So my tangent squared is going to be 5/4, meaning that my tangent of u could either be the positive or negative square root of 5 over 4. First off, there's two things here. First things first, we wouldn't leave this as divided by 4 because the square root of 4 is 2. So I'm going to rewrite this as the square root of 5 over 2, where the square root's only attached to the 5 now. Now it also says at the beginning that tangent has to be positive. So now, instead of calling it positive or negative, I'm just going to be the square root of 5 over 2. So the tangent of u equals the square root of 5 divided by 2. And that is a confirmed number. So we use one of our identities to solve for another value. This has to happen sometimes. So we can figure this out if we know a little bit of information. So let's continue here. Now, the next one that I'm going to want to solve for is, why don't we get the sine? Sine will make things easy. So the one thing that I know is that sine is 1 over cosecant, which I don't have. But I do know another identity, which is that the sine squared of u, or theta, plus the cosine squared of u is always 1. That's another one of our identities. So because I know what the cosine is, I can go ahead and replace that and solve for sine. So I'm going to get the sine squared of u plus -2/3 squared equals 1. So I'm going to get the sine squared of u plus, if I square this, I'm going to get 4 over 9. And then now, when I move the 4/9 over, I'm going to get 1 minus 4 over 9, which I can think of the 1 as 9 over 9. So I'm going to get the sine squared of u to be 5/9. And so my sine of u would be the positive or negative square root of 5/9. Now again, the first step here, we can't leave 9 in the denominator because it is a square. So we're going to rewrite this, just like the previous example, as the square root of 5/3 with the square root only attached to the 5 now. Now, it's going to be either a positive or a negative number. So not both. So we have to think, are they both positive? Is it a positive or a negative? Well, let's look at our other functions and see if we can figure this out. So if we think about our unit circle, okay, we have a negative cosine. So our negative cosines occur all the way over here. So in this section on the left side of our circle. Okay, so our tangents have different values over here. Our tangents are going to have negative values in the second quadrant because when we draw lines from our angles through the origin, they all have a negative slope. They're all going to be positive from the third quadrant, because they have a positive slope going through the origin. So because our tangent is positive already, we know that our sine is going to be negative, because we know that if we have a positive tangent, so say right here, that our cosine is negative and our sine is negative. So that's the only way to make a positive tangent, is either for both of them to be positive, meaning up here, or both to be negative down here. So we know that we have a negative square root of 5/3. So we've got the sine of u to be the negative square root of 5/3. And then we need to find our cotangent and also our cosecant. So those will be a little bit easier to find now that we have all these others. So the cotangent of u is the same as 1 over the tangent of u. Or you can think of it as the cosine of u over the sine of u. It'll be a little easier for us to deal with this definition here to start because we already know what tangent is. So because of this, I know that our cotangent of u, that equals 1 divided by the square root of 5/2, which we can't leave it like that. So we're going to get the cotangent of u to be 1 times 2 over the square root of 5, which is 2 over the square root of 5. But we can't leave it like this. We have to rationalize. And you should end up with 2 times the square root of 5/5. So this is our second to last one. So we know that the cotangent of u is going to be 2 times the square root of 5/5. And our last thing that we have to find here is going to be our cosecant. And we know that our cosecant of u is going to be 1 over the sine of u. Well, this means that the cosecant of u will be 1 divided by negative square root of 5/3. So we get the cosecant of u to be, just like the other problem, we'll flip it and multiply. We'll get negative 3 over the square root of 5, which we have to rationalize again. And we're going to end up with the cosecant of u equaling negative 3 times the square root of 5/5. So if we're given two pieces of information, mainly the value of one of our trig functions and the direction or the positive or negative aspects of another trig function, we can figure out all of this information. So this is a pretty lengthy problem, but this is an example of how to find everything if you're just given a little bit of information. When we move on, so using in manipulating these different functions. So we're asked to simplify the sine of x times cosine squared minus the sine of x. So you want to think of these things as their own little variables, their own little blocks. So because we're subtracting, we need to figure out, in order to simplify, we need to either replace them with something that we can use, or we can factor. Well, the best thing to do here would be to factor, because I've got a sign in every term of my expression. So I can simplify this as the sine of x out front. I then have a big bracket because I've removed it. Okay, so because I've removed it, I now need to write what's been left. So since I removed a sine from sine cosine squared, I'm left with a cosine squared of x. I then have to say, okay, well, what am I left with when I remove the sine from the sine of x? Don't be tempted to say 0, because what we're really doing is we're dividing it out. We've taken that factor away, so we're still left with a factor of -1. So this is the beginning of us simplifying this problem. Now, we can actually simplify this because there are things that link the cosine squared of x and -1. And that is going to be that we know that the sine squared of x plus the cosine squared of x, that equals 1. Well, you may say, well, these don't look the same. Well, we have to work with that. How do I get cosine squared of x minus 1 on one side? How does that happen? Well, what I'm going to do here is I'm going to subtract a sine squared and a 1 from both sides. And what you should end up with is cosine squared of x minus 1 equals negative sine squared of x. Now, I'm going to want to replace these because this is a sine, this is a sine. I can actually combine this and make things a little simpler for myself. So what I'm going to get here is I'm going to get the sine of x times, because I'm replacing these two things, with my negative sine squared, this becomes negative sine squared of x, which if I simplify becomes negative sine cubed of x. So this is the simplest possible answer that I can come up with based off of what I originally started with. So now it says, okay, so what do I do to factor these things? So factoring, I've got to know some rules and different things about how do I deal with problems. So let's start out. So secant squared of theta minus 1. Well, to factor this, they don't have the same terms, so I can't just factor one thing out of each. I've got to notice that this is following a pattern called the difference of squares. And this is mainly that secant squared is secant squared, but 1 is 1 squared. So this is actually going to factor like this: secant of theta plus 1 times the secant of theta minus 1. The difference of squares tells us that this is always true. If we have a square minus another square, they factor just like this. For b, we have 4 tangent squared theta plus tangent of theta minus 3. So this is a little more complicated. This is a full quadratic where we've got a constant and we've got our first term, second term. So what we need to do here is we need to factor, and we need to figure out ways to get the numbers to work the way we want. So first off, I always start off and I make brackets. Okay? Now, instead of using x's and y's like what you've used in the past, your base functions, instead of being x or y, are tangent now, which is fine. So we're just talking in terms of tangents. So we're going to have tangent of theta here, tangent of theta here. We just have to figure out what the numbers are going to be. So we need two numbers that multiply to make -3 also based off of this 4 at the beginning, which makes things a little bit more complicated, that end up adding up to make a positive 1. So what I'm going to have here is, because I see there's a mixture of 4 and negative 3, right? 4 has factors 4 and 1. 3 has factors 3 and 1. I can make those create a 1 for me. So you all have maybe different methods to do this, but this is mine. I'm going to start off and say that I'm going to have 4 tangent and 1 tangent. So I need a number times a positive 4 and another number times a positive 1 that add to make 1. But I need these two numbers to multiply to make negative 3. So one of them needs to be a 3 or a 1, and one of them needs to be a plus or a minus. Well, if I make this a 3, 3 times a 1 gives me 3, and a 1 times a 4 gives me 4. Well, if I'm adding, I can make those make 1 for me. And the way that I do that is by making this a positive 1, so this gives me a positive 4 tangent when I multiply this way, and this gives me a negative 3 tangent as I go that way. So this is how I would factor these in a situation like this, where you get 4 tangent minus 3 and tangent plus 1. Okay, so factoring using a trigonometric expression. Okay, so I have to figure out a way to factor this. So the problem here is that cosecant and cotangent aren't the same kind of base function, so I've got to convert one or the other. Just so happens that I know from our trigonometric identities that 1 plus cotangent squared of x equals cosecant squared of x. So I can convert this cosecant into a cotangent if I want. So I just need to replace them. So I'm going to replace these. I'm going to swap what they equal. So what I'm going to get here is, when I replace this, I'm going to get 1 plus cotangent squared of x. That's just a replacement. And then I'm rewriting the rest of my terms. So minus cotangent of x minus 3. So since I have this, now break this bracket apart. So I get 1 plus cotangent squared of x minus the cotangent of x minus 3. If I simplified this and tried to turn it into a quadratic, I'm going to get cotangent squared minus cotangent of x, and then I'm going to get a minus 2. So kind of like the last problem, I can factor this. My base function is now cotangent instead of tangent like the other problem. So each of these is going to be a cotangent. This one's much easier because I don't have any coefficients in front of cotangent squared. So both of these are the numbers in front of cotangent are going to be 1. So I can write these a little bit further back. This is a lot easier problem. I need to find two numbers that multiply to make negative 2 that add to make negative 1. And so this should be pretty simple for us. It's a negative 2 and a positive 1. So this would be how I factor this particular expression, but I can't do that until I get everything in terms of the same trig expression. Okay, so the next example says simplify this expression. So I've got sine and I've got cotangent times cosine. So I need to go about this. Because I'm multiplying over here, I'm going to want to convert those to sines and cosines. So I'm going to get the sine of t plus the cotangent of t. So this would be the cosine of t over the sine of t. And then my cosine is just going to be cosine of t over 1. Well, this equals just the sine of t plus the cosine squared of t, because the cosines will multiply, over the sine of t. Well, this isn't good enough. I've got to find a way to combine these to make things work out a little bit better for me. So I'm going to think of this as the sine of t over 1. Now, when I go through and do this problem, I'm going to have this, I need to add these fractions together. So the method that I've taught you guys is you multiply down, so you get sine squared of t. You then take the sign in the middle, plus. I then multiply up to get the cosine squared of t. And you then divide by the denominators multiplied together, which is the sine of t. You may think, why did I do that? Why is that helpful? Well, if you notice, one of the identities that we've learned is available on the top. And that is that the sine squared of x plus the cosine squared of x always equals 1. So because this is here and that is here, I can replace them. And what am I going to replace it with? The number 1. So the whole numerator just becomes a 1. The denominator stays a sine of t. Well, I know 1 over sine of t, and that is the cosecant of t. So this is the simplified version of this entire expression. And lastly, just like this last problem, it's going to say perform the addition and simplify. So I need to start out and do what I had just done, right? Multiply down, which is sine squared of theta, multiply up, or excuse me, I need to add multiplied up, which is going to be the cosine of theta times 1 plus the cosine of theta, and then divide by the denominators multiplied, which is 1 plus cosine of theta times the sine of theta. So I've got a little work that I got to get done. So my numerator, when I simplify it, this is going to be the sine squared of theta plus cosine of theta plus the cosine squared of theta. And for the meantime, I'm going to leave the denominator factored. It's always generally a good idea to leave denominators factored just so that you can cancel stuff later. Well, like in the last problem, I know that the sine squared of x plus the cosine squared of x is always equal to 1. And you may say, well, how is that helpful again? Well, I have a sine squared and a positive cosine squared. So even though they're out of order, that doesn't matter. I can actually replace both of these with a 1, and I'm going to go ahead and do that. So this is going to give me cosine of theta plus 1. And my denominator stays the same, which is going to be 1 plus cosine of theta times the sine of theta. Well, if you see that I have a cosine theta plus 1 and a 1 plus cosine theta, which are the same, I can cancel those. So you want to be careful. The numerator doesn't just go away, it becomes a 1 because there's still a factor of 1 there, and I'm dividing by the sine of theta, which, just like the other problem, I know to be the cosecant of theta.